Example number 3. Tell whether the table of values represents a linear, exponential, or quadratic function. Then write the function. So we're still going to do the same thing we just did, except now we actually have to write the function once we figure out what it is. So x values 0, 1, 2, 3, 4. Great, they go up by 1. 12 to 0, 0 to negative 4. It doesn't look like I'm multiplying by anything, so I'm going to start with my differences. How do I get from 12 to 0? I subtract 12. How do I get from 0 to negative 4? I subtract 4. How do I get from negative 4 to 0? I add 4. And how do I get from 0 to 12? I add 12. First difference is not the same, so I know it's not linear. So I do it again. How do I get from negative 12 to negative 4? I add 8. How do I get from negative 4 to 12? Or I'm sorry, negative 4 to 4? I add 8. How do I get from 4 to 12? I add 8. My second difference is the same, so I know that this is quadratic. Now, if it's quadratic and I have to write the function, I know that I'm going to be dealing with f of x equals ax squared plus bx plus c. And I have to use the quadratic one is the hardest. Linear and exponential, not so bad, but quadratic is going to be the hardest for us. I have to use what I'm given to try to figure out how to write this function. So I recommend starting with a graph because when I look at a table of values, it doesn't mean a whole lot. So 0, 12, I know I'm going to be up here at 12. 1, 0, I know I'm going to be over here at 1. 2, negative 4 is going to be somewhere down here. 3, 0 is going to be right here. And then 4, 12 is going to be up here. So if you look at what you're given, you're actually given a nice parabola. And even more so, you're given the vertex. So I know that the vertex is going to be at 2, negative 4. So given that I have the vertex, I'm also given the x-intercepts. But I personally like to deal with vertex form just because I'm more comfortable with it. If you like intercept form, use it. But I'm going to go with y equals a times x minus h squared plus k. And this is vertex form. Now I know my vertex is at 2, negative 4, so y equals a x minus 2 squared minus 4. Then I'm going to look at my graph and I'm going to go, okay, can I figure out my a value? And keep in mind your a value means over 1. If you can go over 1 and do something, then you can probably figure out your a value. If not, we have a problem. So from my vertex, this is at 2, right? Over 1 would take me to 3. And then I have to get up here to this dot. So my vertex, we said, was at 2, negative 4. And I went over 1, up 4. Or I went over 1, up 4. Because I'm down at negative 4. And these went up to 0. So I went over 1 to 1, up to 4. Over 1, up to 4, which means my a value is positive 4. So at this point, y equals 4 times x minus 2 squared minus 4. And then at this point, I'm going to go, did it say anything in the directions about writing this thing in standard form? I don't think so. So guess what? I'm done. I'm going to leave it like that. It just said write a quadratic function. That is a quadratic function in vertex form. You're done. Letter B. Okay, first of all, we're going to check our x values. Negative 2, negative 1, 0, 1, 2. Those are increasing by 1. We're good. Then I'm going to go from 0 to a half. How do I get from 0 to a half? I add a half. How do I get from a half to 1? I add a half. How do I get from 1 to 1.5? I add a half. How do I get to 1.5 to 2? I add a half. These are the same. These are the first difference, which means it's linear. Linear means y equals mx plus b. M, we said, was the slope. B, we said, was the y-intercept. Where's the slope? This is the slope. Okay, so your slope is your rate of change. So now we've got y equals 1/2 x plus the y-intercept. Where's the y-intercept? It's right here. It's where your x value is 0. So this is your y-intercept. It's at 0, 1, so plus 1, and that is the equation of that linear function. Letter C, x values, -1, 0, 1, 2, 3. They're increasing by 1. We're good to go. 16, 8, 4, 2, 1. I'm looking at that going, that doesn't look like it's adding or subtracting to me. But if I take 16 and I times it by a half, by the way, has to be multiplication. Can't do division here. So times it by a half, I get 8. 8 times it by a half, I get 4. 4 times it by a half, 2 times it by a half. That to me looks like a common ratio. This is exponential. So y equals a times b to the x power. A, remember we said was your y-intercept. B, we said was your common ratio. Where is your y-intercept? Kind of the same with your linear. It is where your x value is 0. So we're going to have y equals 8 times our common ratio. What's the common ratio? It's your 1/2. So we're going to put 1/2 to the power of x, and you're done. Now, whatever you do, do not multiply that 8 and that 1/2. Because of order of operations, you have to do exponents first. So you'd have to take 1/2 to whatever power. Given that we don't know what that power is, you can't do this, meaning you can't do this, so you have to leave the 8 and the 1/2 separate. If you would take 8 and multiply it by 1/2 and get 4, we'd have a big issue there. It wouldn't be the same thing. So leave it like that. That's as far as you can go.